Hello, students. In today's session, we are going to discuss a topic. The topic is center of mass of continuous rigid body. So we have seen the particles and their center of mass. When two particles are considered in one dimension, two dimension, and three dimensions, right? So this is like the, another concept of center of mass. We are considering this like for a continuous rigid body. Continuous rigid body means we can say consider a solid body like a rod, or we can say like a sphere. So if you want to calculate the center of mass of continuous rigid body, how to calculate? So here, if you remember the formula for center of mass for the particles, this was the formula m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. This is for three particles I'm writing. If n number of particles are there, we can write this as mn xn plus so on. This will be mn. So this is the general formula what we have already studied, but this is for the number of particles. If we are considering two particles, three particles, n number of particles if we are considering. Now what I say here is, here if you have instead of particles continuous body is there, continuous rigid body is there, then this summation, that is plus sign, is replaced by an integration sign. I repeat once again, when the number of particles we are replacing by a continuous body, continuous rigid body, then the summation sign, that is plus sign, is replaced by an integration. Summation we can have plus, that is sigma, as well as for integration. So here for continuous rigid body, we are replacing this plus sign with integration sign. So the formula will become integration of x dm by integration of dm. Integration of x dm. Dm is a small mass element, and this is the integration of dm. Now this integration of dm means this is the total mass. Actually m1 plus m2 plus m3 and so on, this is considered as the total mass. So therefore I'm writing here the total mass as integration of dm. In some books they have mentioned this as the, थोड़े से books में इस तरह से भी है बेटा, you can write like this also, it makes no difference. But prefer this one. Why? Because we need to integrate. So if suppose total mass is given, this we can use, but in general the problems will be mentioned in terms of like x and dm. So we have to go with this formula only. Now here we are writing the integration of x dm by integration of dm for x coordinate. For y coordinate, if you want to go for that, then we can go for like this, integration of y dm by integration of dm. In the same way, if you want to go for z, integration of z dm by integration of dm. So these are the formulae what we have to remember. This is the for x coordinate, this is for y coordinate, this is for z coordinate, and integration of dm can be written as just the total mass of the object or the body whose center of mass we need to calculate. Now what we do here is, based on the concept of integration of x dm by integration of dm, that means we are calculating the center of mass of continuous rigid body. We have one problem. So what is that problem? We are going to see, but first of all, you take down this fast. Students, let us move to a problem where we are going to use the concept of center of mass of continuous rigid body. The first problem what we are discussing here, it is on the board. If the linear density of the rod of length L varies as lambda is equals to kx square by L. So here linear density is given. We can write lambda is equals to kx square by L, where k is a constant, x is the distance of any point from one end, then find the distance of the center of mass from the end at x is equals to 0. So we have to start calculating the center of mass from the end x is equals to 0. So how to go with this? First of all, for solving such type of problems, we should know what is the linear density, because the one word is a new word for you, linear density. Generally we study volume density. Volume density means mass by volume. I repeat once again, volume density. Volume density means mass by volume. So here we are discussing the linear density. Linear density means mass per unit length. Mass per unit length. So here what I do, this is the linear density. So therefore this I'm writing it as dm by dx. This is a linear density, mass per unit length. Dm is the mass and dx is the length. So this is how much, kx square by L. Then what is this dm? Dm is equals to kx square by L, cross multiply it. What we are getting? Dx. I'm just cross multiplying. Now our aim is to calculate the position of the center of mass for the continuous rigid body. So what the formula we can use here is x integration of x dm by integration of dm. Now let us see. Integration. What is x? X as it is. But what is dm? Dm is this part. You can see dm. I have to write this part. That is dm is kx square by L dx divided by integration of, what is this integration of dm? Dm is kx square by L. So this is kx square by L and this is what? A dx. Now students, you can see clearly k by L is a constant. Here also k by L is a constant, and moreover the concept what we are using here, the concept of definite integration. That means limits also we need to apply. How the limits to be applied? We have to start from x is equals to 0. We are starting from x is equals to 0 and the length of the complete rod is L. So therefore here I specify the limits also 0 to L and here 0 to L. Now how to proceed with this? Pay attention. X into x square, it is x cube by, and this is k by L. I'm taking it outside. So pay attention, this is k by L integration of 0 to L. I repeat, k by L is outside, 0 to L integration x into x square, it is x cube and this is dx divided by what we have here, k by L. Again it is a constant, so I'm taking outside k by L integration of what? X square dx. X square dx. So this k by L and k by L get cancelled. Now pay attention. What is the integration of x cube? It is similar to x power n, and the formula we know x power n as x power n plus 1 by n plus 1. So therefore 3 plus 1, that is 4, x power 4 by 4. So therefore here integration, if you apply, what I am getting here, x power 4 by 4 and the limits are from 0 to L divided by integration of x square. Integration of x square is how much? What is the integration for x square? X power n plus 1 by n plus 1. N is how much here? It is 2. 2 plus 1, that is 3. So therefore here I write x cube by 3 and here from 0 to L. Now students, what we need to go for this is, this you can see clearly, upper limit minus lower limit. The concept of upper limit minus lower limit, that is definite integration we are applying. If I apply upper limit, in place of x I have to write L. So this is L power 4 by 4 minus, this is 0, no? So lower limit is 0 power 4 by 4 divided by, this is L cube by 3 minus 3 cube, 0 cube by 3. Now this value, if you see, this will be what? L power 4 by 4 divided by L cube by 3. Now students, we can just cancel L cube and here L power 4 means, if you cancel this L with L cube with L cube, how much remains? What remains in the numerator? Just L remains. And this 3 will go up, 4 will come down. So this is what? 3L by 4. So this is the position, that is 3L by 4 is the position of the center of mass for a rod of length whose linear density is varying as kx square by L. Hope you understood the question along with the solution.